Germany's newest Eurofighter just took to the skies, and on paper, it represents the most advanced version of Europe's flagship fighter ever built. It features a powerful new AESA radar, improved avionics, expanded strike capabilities, and technology funded partly by wealthy Gulf customers. But here's the real question: is Germany modernizing for the wars of tomorrow, or investing billions into a fighter that is already being overtaken by fifth-generation aircraft? As Europe races to rebuild its military after Russia's invasion of Ukraine, the success or failure of the Eurofighter could determine whether Europe's defense industry remains globally competitive or falls even further behind the United States and China. The Eurofighter Typhoon has served as Europe's premier multi-role fighter for more than 2 decades. Developed jointly by Germany, the United Kingdom, Italy, and Spain, it entered service in the early 2000s and was designed primarily for air superiority before gradually gaining ground attack capabilities. Now Germany has reached a major milestone. The first Eurofighter built to the new Tranche 4 standard has successfully completed its maiden flight, keeping deliveries on track for later in 2026. The aircraft forms part of Project Quadriga, under which Berlin ordered 38 new Eurofighters in 2020 to replace its aging Tranche 1 fleet. Although the older aircraft have not reached the end of their structural service life, upgrading them to modern standards proved too expensive and technically inefficient. At the same time, Germany is pursuing a dual-track strategy. Alongside these Eurofighters, it is also buying 35 American F-35A stealth fighters to maintain NATO's nuclear-sharing mission and gain access to fifth-generation capabilities. That combination reveals a much bigger story about Europe's defense ambitions. The first reason this new Eurofighter matters is that it finally fixes one of the aircraft's biggest technological weaknesses. For years, earlier Eurofighters relied on the mechanically scanned Captor-M radar, a system that had become increasingly outdated compared to modern active electronically scanned array, or AESA radars. Unlike older radars that physically move an antenna, AESA radars use thousands of tiny electronic transmitters to steer radar beams almost instantly. That allows faster target tracking, better resistance to electronic jamming, longer detection ranges, and the ability to monitor multiple targets simultaneously. Germany's Tranche 4 aircraft will receive the Hensoldt-developed ECRS Mark I AESA radar, bringing the Eurofighter into line with most modern combat aircraft. This upgrade also highlights how international defense cooperation works. Development of many Tranche 4 technologies became economically viable because export customers such as Kuwait and Qatar purchased advanced Eurofighters years earlier. Those contracts helped finance research and development that Germany now benefits from. The aircraft will also integrate the Taurus KEPD-350 long-range cruise missile, capable of striking heavily defended targets from hundreds of kilometers away without exposing pilots to the most dangerous air defense zones. That significantly expands Germany's long-range precision strike capability at a time when NATO increasingly emphasizes deep strike operations. But modern electronics alone do not automatically guarantee battlefield superiority. The second issue is that the Eurofighter still faces structural limitations that software upgrades cannot completely solve. The fighter remains a fourth-generation design that first flew in 1994. Despite continuous modernization, it lacks one defining characteristic shared by fifth-generation aircraft, such as the American F-35, the Chinese J-20, and Russia's Su-57, low observability, commonly known as stealth. Stealth dramatically reduces an aircraft's radar signature, allowing it to detect opponents before being detected itself. In modern air combat, seeing first often means shooting first. Beyond stealth, the Eurofighter also carries inherent design compromises. Its relatively small radar aperture limits the size and power of future sensors. Its combat radius remains shorter than larger aircraft like the F-15EX, while its payload capacity also trails several competitors. These limitations help explain its export record. Although initially envisioned as Europe's common fighter, the Eurofighter has consistently lost major international competitions against the F-35. Countries including Switzerland, Finland, Germany, Belgium, Poland, and others have selected the American stealth fighter for at least part of their future fleets. Even the United Kingdom, one of the Eurofighter's founding partners, has shifted future investment toward expanding its F-35 fleet while gradually retiring older Typhoons. Germany therefore faces a strategic balancing act. Berlin wants to preserve its domestic aerospace industry, while ensuring its air force remains capable against rapidly evolving threats. Purchasing both Eurofighters and F-35s represents an attempt to achieve both goals simultaneously, and that balancing act connects directly to an even bigger transformation taking place across global air power. The third and perhaps most important lesson is that modern fighter competition is no longer just about individual aircraft. It is about entire technological ecosystems. Today's air forces increasingly fight as integrated networks rather than isolated platforms. Modern fighters exchange real-time targeting data with drones, satellites, airborne warning aircraft, electronic warfare platforms, and ground-based missile systems. The United States is investing heavily in collaborative combat aircraft, autonomous drones designed to accompany fighters into battle. China is rapidly expanding similar programs while fielding advanced aircraft such as the J-20 and new stealth drones. Russia continues developing its S-70 Okhotnik unmanned combat aircraft alongside the Su-57. Europe, meanwhile, is betting on its Future Combat Air System, or FCAS, a sixth-generation program led by France, Germany, and Spain. However, repeated industrial disagreements and funding challenges have delayed progress. That means the Eurofighter must continue evolving for another 2 decades while Europe waits for its next-generation replacement. Its open architecture allows continued integration of new missiles, electronic warfare systems, and sensors, extending operational relevance even as newer aircraft emerge. Nevertheless, the pace of technological competition continues accelerating. Artificial intelligence, autonomous systems, electronic warfare, and advanced networking increasingly determine combat effectiveness as much as raw aircraft performance. That reality means future upgrades may prove just as important as today's hardware improvements. For Europe, Germany's new Eurofighter demonstrates that the continent remains committed to maintaining an independent defense industrial base despite growing reliance on American technology. For NATO, Germany's mixed fleet of Eurofighters and F-35s creates complementary strengths. The F-35 provides stealth penetration and advanced sensor fusion, while upgraded Eurofighters contribute air defense, long-range strike, and high sortie rates during sustained operations. Germany's newest Eurofighter proves that Europe's aerospace industry can still innovate, but in an era defined by stealth, artificial intelligence, and networked warfare, the real challenge is no longer building a better fighter. It is building an entire combat ecosystem that can keep pace with the world's fastest-moving military technologies. If you enjoyed this analysis, don't forget to like the video, subscribe to the International Desk, and turn on notifications so you never miss our next deep dive into the geopolitical stories shaping our world.